Great. Well, welcome everybody. This is exciting. You are tuning in for Communication is Key, setting up microservices for success. So if that's what you're looking for, you are in the right place. If you're looking for something else, you might want to recheck whatever link you click to get here, but you are certainly welcome no matter what. My name is Jacob Evan Smith. I am here representing an amazing tech company based in Southfield, Michigan, Detroit area, called Altimetrik. We are a digital transformation company, which essentially helps clients stay ahead of the curve with technology, with the ever-changing landscape of technology. So yeah, I'm here joined by my wonderful colleague, Ryan Robinson. Ryan, give a wave to people, wherever you're at in their screen. And so if you have any questions about Altimetrik or what we're doing, we would love to share more detail. We're here representing a project called Collider, which is essentially the community-facing branch of the Altimetrik company. We regularly host tech talks and workshops and different things to help level up the local software ecosystem in Detroit, but also in this virtual time we find ourselves in. You know, folks are tuning in from all over the country and all over the world. So first and foremost, I was hoping that on that note that folks could drop into the chat with where you're tuning in from, so that we can just get a sense of where folks are coming in from. We appreciate that. So again, if you want to learn more about our project, we'll drop some links in the chat here, but we want to go ahead and get started here on tonight's topic. So again, communication is key, setting up microservices for success. I'm excited to intro our presenters tonight. We've got two very special guests, Teja and Abhishek. Both Teja and Abhishek work for the Altimetrik team. They are both, Teja is a full stack Java developer, and Abhishek is a lead software engineer at Ford Motor Company. So they both work full time on software engineering and are both very familiar with the microservices architecture framework from a number of different angles that they can explain much better than me. And that's what we're going to be diving into today. The goal of the conversation is to kind of provide a high-level overview of what are microservices, how can you use them, and why is it important, essentially. And then we're going to be opening it up and really trying to make this an interactive conversation. So as we go through the talk, please feel free to drop questions in the chat, and we'll try to work that in as quickly as it makes sense to do so. So yeah, without further ado, I want to go ahead and pass it off to Teja and Abhishek.
Hello, everyone. Yeah, my name is Abhishek. Thanks for the introduction, Jacob. I have been working with Altimetrik and Ford Motors Company for about 4 years. And I have specialty in building and communicating with microservices. So that's what we're going to try to do today, share some knowledge as well, but and then maybe dive a little into code and try to build up our own microservice from scratch. Just a little demo. So yeah, we're gonna be do that. So maybe Teja, you can start over.
Yes. So just a little bit introduction of myself. So as already Jacob introduced me, I'm Teja, working for Ford as a full stack Java developer for a couple of years, working with Altimetrik. So let's get started. Before that, let me share my screen. I have made a presentation for you guys. Okay, so before going into that, very happy new year for all of you guys. So I feel if you have to learn any topic, you have to answer three basic questions: what, why, and how. So only then I feel your knowledge will be complete. So here today I'll try to answer these questions: what, why, and how regarding the microservices. Okay. So even before going into microservices, let's talk about the monolithic architecture. So this is the traditional way of building the applications. Mono means single, lithic meaning stone. It's a whole single program containing all the components together, tightly coupled with each other. So this is a single tier architecture, and most of the companies are still following this architecture. So the advantages of this architecture include it's very easy to develop, very less complexity, and easy to deploy. So when it has these advantages, why people are talking about microservices? Because the world is changing. We are moving into agile. We need continuous deployments and developments. So in such scenarios, we are thinking of other architectures like microservices. Now let's see why do we not require monolithic in this scenario. First thing is, as I told you, everything is in one single program. This is very rigid and tightly coupled. Say, for example, if some enhancements come up in your application, and if you have to make some enhancements, then it's very difficult to do it. And if you have to deploy the application, there would be some downtime for the application. You have to bring the application down, and then you have to deploy, which is not a good thing here. So, along with this, some other disadvantages include a single point of failure, meaning if there is some bug in any one of the components, the entire application is affected. And since, as I told you, it's one single program, performance is also slow here. And coming to developers, if some new developer comes into team, it's a one single whole big program. It's also difficult for them to understand and dive deep into the code as soon as they enter the team. And as I told you, the world is in agile. So if you have to make continuous developments and deployments, then there are few challenges with this architecture. So here comes our famous microservice architecture, which most of the bigger companies are using. So what does it say? So micro meaning small, services is the service which gives results to the customers. So it's a smaller services, meaning the whole single component is broken down into smaller independent services, which is processing the requests. So why we need them? As I told you, these are single independent services. These are loosely coupled. If some enhancement comes up in future, you can just work on one single service without affecting the entire application. And so it means it's not single point of failure and fault isolation. If there is bug in one single service, only that service is something which developers are working on, and entire application continues as is. Other services serve the customers. And as I told you, this is agile and flexible, and we can do continuous developments and deployments very easily using this architecture, since these are loosely coupled. And mixed technology stack, meaning if it's monolithic, you just have to use one technology stack to develop the entire program. But here, since you have different microservices, you can use different technology stacks, meaning one service can be developed in Java, one you can develop using .NET, and it's very flexible in that way. And also granular scaling. As I told you, if you have to make any modifications at granular level, since this is broken down, it's very easy. It's like, basically the divide and rule concept. So, but as a coin has two sides, even these microservices has some disadvantages, like high complexity, meaning it's not that easy to break down a whole big program into smaller services. You have to think a lot, and you have to see how you are going to organize it. And coming to consistency, meaning, for example, each service has a different database, and if the data has to be consistent between the databases, you have to be little careful when you are dealing with microservices. And also, since there are several services, you have to take care of inter-service communication, how these services talk with each other. That's one of the complicated thing while dealing with microservices. And if you are dividing these microservices between different teams, you have to make sure all the teams coordinate with each other, and they deal very easily with microservices. Okay, so when I'm saying microservices in this meetup session, it doesn't mean that it's one stop solution. Some organizations which have not very complicated applications can still go with monolithic architecture. Again, it depends on your requirements, on your team size, and your application size. So you have to consider all these factors if you are thinking about microservices. So as you can see the screen, this is how different the monolithic architecture is from microservice architecture. So in monolithic, as I told you, it's one single program containing the user interface, the business logic, or the databases. And in microservice, it's all different microservices dealing with different databases or a single database. Again, it depends on how we are architecting your application. Okay. And yeah, if you're planning on moving from monolithic to microservices, there are few factors that you have to keep in mind. First thing is degree of independence, meaning you have to decide how independent each microservice is with the other. For example, you can choose different databases for different microservices, or you can choose only one single database for different microservices. So it depends on your application. So that's one factor you have to consider. And then code organization. When I say code organization, you might be using GitHub or Bitbucket. So you can choose like if whether you want to maintain one single repository with several folders for different services, or you could create different repos. So it's again one other factor that you have to consider. And then technology stack. Since you have multiple services, you have to carefully choose which technology you are using for microservices. But whereas in monolithic, it's just one single program, so it's very easy to choose which one you want to go for. And then operational complexity. When I say that, I meant the infrastructure and how we are monitoring. So this is one other factor that you want to take care when you are trying to move to microservices. And then continuous delivery and team organization. So this is something, since there are several services, you have to plan on how you are continuously delivering them. So are you trying to set up some automated pipelines, or how you are going to deploy them? So that's one thing. And team organization. So how we are dividing these microservices for either development. You are maybe like one developer taking one microservice, or maybe a smaller team dealing with one microservice. Again, that's your choice. So but these are some of the factors which I would like to highlight when you are moving from monolithic to microservices. So I hope you got some idea. For the beginners who are very new to microservices, maybe you got some idea of what these are and why should we go for them. So now I would like to hand over to Abhishek. Abhishek, can you please show us some demo on how these actually work?
Yeah, sure. Thank you for the presentation, Teja. So before I move into the demo, do you guys have any questions that we can address?
Is there generally a sense of like how big a team would be before a system like this would be implemented, or is that it's really dependent on the needs?
It's actually mostly dependent on the team. You can start small, and as you grow bigger, right, you can hire more people, and then more people can work into different parts of the microservices as well. And depending on how your team is structured, that same microservices can be further divided into smaller microservices, right? So it actually depends on how your team is structured and what's the scope of your application. All right. I guess we can get started with the demo. So let me try and share my screen. All right. Are you able to see my screen?
Yes.
All right. So I have created this small application that is kind of a part inventory, right? So it has two endpoints as of right now. So these are REST endpoints. One is post, the other one is get, right? So what this post does is it saves any part into the inventory. Okay, so what we can do is we can try this out now. Let's say I want to add a part name, let's say tire, right? And then name is XYZ tires. And then price per unit is say $90. Okay, so I can just execute that. And then you can see over here in the response, it says that it has been saved. Okay, so, oh, sorry, over here. It says that this part has been saved successfully. Right? So So what's happening in the background is this is one microservices that takes care of the part, right? So if you see here, so over here, so this is the database that it's storing the part in. So as you can see that number 8 over here, this row signifies the tire that we stored earlier, right? So this is how you can store the any part. Now what I can do is I can get the details on that same part using this another service or another endpoint that I've created. So let's see. So the part ID is 8 over here. So 8, execute this. And then you can see that the name and the price per unit of this application. So now this is a standalone application that I have created. It's a microservice. So based on the architecture, what Teja shared a little earlier, what we can do is we can use another microservices to leverage this one and do any kind of business logic, any kind of structure that we want to create, right? So for that, this is a completely new microservice called workshop. Okay, so what this is doing is it would try to calculate the cost estimation based on what you are trying to do. So for instance, if you are trying to go to a workshop to do your breaks, right, what I can do is I can just put in the estimate type as break, and then part ID, let's say 1. Let me see what I have. Let's say I have a brake fluid, right? So let me see, it's brake fluid, and then I just need one of them, right? So if I can execute this, you can see over here that the total cost estimation is 130, right? So what's happening in the background of this application is it's connecting with the one that I showed earlier, the parts application, and it's pulling the cost of each part. Like over here, it says that the brake fluid price for each brake fluid is $30, and there is some labor charge that's associated with the brake, so which gives us an estimate of $130, right? So this is all happening between two applications, and the communication is done through Fein, so which I will show you in a little bit. But this can this can be anything else. Let's say I want to add brick pads as well. All right. So for instance, brick pads is 4, right? 4 brick pads, and then I need 2 brick pads. Let's say when I execute this, you can see that brick pads 4.82. Okay, I missed a comma over here. So you can see that the total cost estimate leads to $120. So this is what's happening in the background, right? So now what we can do is we can create our own microservice and leverage any of these microservices to do our own thing, right? So to do this, what we can do is we're going to use a Spring Boot application. Those of who you are not familiar with the Spring Boot application, is it's a very simple framework for Java language, right? So you can just go to the startspring.io. You can select the language as Java. It also supports Kotlin and Groovy. For now, we're going to do a Gradle project, and I have selected the Spring Boot version as 2.3. So let's say these are just the package structure that you want to work with. Let's say microservice demo, right? And this is a jar file. And since I have Java 8 installed in my machine, I'm just gonna use Java 8 over here, and you can add dependencies too over here. So for simplicity, I have just added these 4 dependencies, but you can add more as you wish, right? So for instance, you have REST repository, Spring session, and all those kinds of dependencies which you can use. Spring also supports SQL, JDBC, and then security as well. So you can play around it if you want. But for this demo purpose, I just need Spring Web and OpenFeign, since we are using Fein Client. Okay, so let me generate this project. All right, let me open a new IDE. Okay, I'm opening over here. So before I do that, I need to extract the files. Right, so downloads, Microservice demo, open it in a new window. So while this is building, do you guys have any questions from the application I showed earlier?
Abhishek, one question here. My name is Nitin. So you just shown one microservice is connecting to other microservice, right?
Yes.
So my question is that is always is happening direct connection to one microservice from microservice A to B, or is there something intermediary thing, some broker we need to go there and reach to the other microservice what we are connecting to?
Oh, so for this case, you just have to connect with one service to the another, but you can use any like message broker service such as RabbitMQ or anything, right? Which can listen to the message, and then you can do your thing once you have any kind of message in the message server. So for this purpose, it's just direct connection.
And I have one more related question. So,
Sure.
So the microservice B, anyone can connect to microservice B, right?
Yes.
So is there any, probably I know this is a very a basic example you are showing, but my concern is that how we restrict accessing from, because I don't want to have give access to all microservices.
Mm-hmm.
I need to give some particular microservices. How do we restrict?
So there is like Spring Security and other security frameworks such as OAuth 2, which allows you to restrict your application or your endpoints to be consumed by certain consumers, where you can define like, okay, XYZ consumers can only call me, right? With such, let's say it's a username and password based consumer, right? So only if you have a valid username and password, you can then give me a response back, right? If not, you'll just give an error, right? There is one that type. There is another OAuth 2 type, which is app-to-app communication, where you can use a certain client ID to communicate with each other, right? Let's say I'm service A, I want to connect to service B. If I need to do that, I need to register myself into service B. Then only I can make the connection. Let's say there is service C who also wants to make the connection, right? But if that service is not registered to service B, you cannot do that. Right? Does that answer your question?
Makes sense, Abhishek. This is what I was looking for. Yeah, thanks for
Sure.
that. So, okay, one related question. So, if there are hundreds of microservices, and we is this always possible that I need to register the microservices, be the particular microservices which I need to have access, or is there some common registry available or something like that?
That depends on the microservices itself, right? So if your let's say for previous example, if the microservice B needs needs your consumer to be registered within the microservice B, then you need to connect with microservice B, right? There can be some other servers such as any authorization server that takes care of authorization, and you don't have to go through microservice B for that, and that might be possible.
Okay. Thanks, Abhishek. Yeah, it's
Sure.
well explained.
Sure, thank you. All right, so now the project is set up here. So let me see what I have. So out of the box, you'll get this main application over here, right? And then if you see build.gradle, these are the dependencies which we earlier selected from the Spring website. So now what I can do is I can just run this application. But before that, what I want to do is I want to change the server port because as we can see over here that this part application was running in localhost 8080. Okay, so localhost, sorry, 8080 port is the default port that is provided by Spring, right? So to change that, you just have to put like server.port goes, let's say 8082, for example, and then you can just start this application.
Hey, Abhishek, we have a question in the chat as well. Vin was wondering, do you use REST template to communicate with other microservices?
Yes, so REST template is a good way to communicate with other microservices as well. But right now, what we are trying to do is we're trying to use Fein because it's just declarative. You can have a separate class which declares that, okay, this is the endpoint that you want to connect to, right? And it also makes a separation of your client with your whole business logic, right? So that way we can have some kind of separation. So yes, REST template is also a good way to do it. But for this purpose, we're going to try and use a Fein Client. All right. So as you can see that over here, it says that the Tomcat has started at port 8082. Okay. So Tomcat is an embedded server within the Spring Boot application. So you don't have to create or install any other external server. This does the trick by itself. Okay. So now let's see. The server is ready. So what we're going to do is we're going to try to use Fein Client to connect with the parts application that we used earlier. So for that, I'm going to just separate a package. Sorry. Client, let's say I want to name this as what client, right? Actually, it's an interface. Okay. So to use Fein Client, what we're going to do is we're going to use an annotation called Fein Client, right? So here what I can do is I can just give a name for this client, let's say parts client, right? And then I have to give the URL, which we were using earlier. So for instance, this is the parts API, right? So this part is going to be your API along with this URL, right? So for URL, I'm just going to use this localhost 8080. Okay. And then I can create a method over here using response entity that gives me parts response, right? So for this simple application, we're going to just print the name of the part along with the cost of the part. Okay, so I'm just going to name it as print part. All right, so I'm gonna need the ID to do that. So I'm just gonna use the long ID for this. Okay, so as you can see, this is red, which means that this ID doesn't recognize that this class has been created, right? So what we need to do is we're just gonna create the class, and I like to use a different package for this. So once this is created, you will see that the error would go away, right? So now to make the call to this directory ID, right, which would give me a part by the ID name, I'm going to use this endpoint. Okay, so since this is a get method, get is one of the HTTP method, I'm going to use a get mapping. So here API slash, so I'm using API slash because this is the base path of this endpoint. So API part slash and then directory slash ID, right? Oh, sorry. So ID. So since this ID is going to be a path variable and dynamic based on what you send it, so I have to put it in this curly braces, right? So what this is, it's a path variable. So I need to annotate it as a path variable, which means that it's going to be embedded in the path itself. Okay. Now, once we have created this, I can create a new package called service that will have all the business logic. So I'm just going to create a class called Microservice demo service. All right. So since this is a service class, Spring needs to know that. Okay, so I'm going to annotate it with service. Okay. Now Spring uses dependency injection with AutoWired to inject any other dependency into the class so that we don't have to create it manually. Spring takes care of it. So to do that, I'm just gonna use AutoWire. First, I'll just define that what I want to AutoWire. So port client. So I'm just gonna AutoWire this, right? What this will do is this will just inject it into this service class. So now I can create a method. So let me just return a string over here. Print part, right? And then I will need a ID from my controller. So now what I can do is I can get a response object, parts response. So now I can use this part client to get the print client, right? So I can pass the ID over here, right? This is showing me error because the part client returns an response entity object, but here I'm parsing it as a parts response. That's why. So to get the parts response from the response entity, I just need to get the body of that response entity, right? Now, this parts response doesn't have anything as of right now. So we can go back and see what this guy returns. So it returns name, description, and price per unit, right? So what we're gonna do is we're gonna just add these 3 parameters into this class, right? So for simplicity, I'm just gonna copy paste it. Right. So these are the 3 parameters. And then we have added something called Lombok. So what this does is it helps us to annotate the class, and then that would help us to create the setters getters, and then as well as the constructor of this Pojo class. All right, so as easy as that. Now, once I get this response, what I can do is I can extract the the parts cost and the part name from this response. So let me do string part name as response dot get name, right? And then double price, right? Price equals response dot price per unit, right? So once we get that, what I can do is I can just return price per unit of I can just append the part name over here. Is I can put a $sign over here, and I can just put the price. All right, so this returns me a string that says the price of XYZ is XYZ, right? So now I can create a controller. So the controller class is the class that actually gets the request whenever you are trying to hit it from your client, right? So just give me some controller. I'm just gonna say demo controller. So here, so since this is a controller class, Spring needs to understand that. So I'm just gonna put controller over here. And then here, as earlier, I need to auto wire it to service class. Auto wire it. Right, and then here I can create a method. Let's say get part detail. Right, and this needs a long ID. Right, so what I'm just gonna do is service dot print and then long ID, just ID. Right, and then I can just return this. Right, and now you need to define the URL that you'll be calling to get the details on this. So for simplicity, I'm just going to use get mapping over here, right? So I can say that this is microservice / demo / and then I can pass in the ID, right? And since this is again a path variable, I just need to let Spring know that this is a path variable, right? All right, I think that's it. So let me run the application, see if there are any errors. Oops, there seemed to be some error over here. Now the error is, I think we have to let Spring know that we are using Fein Client. So enable Fein Clients. All right, you can see over here that the Tomcat has started at port 8082, right? So I'm going to use this tool called Postman, which is used to make a call to your endpoint. So I can just use localhost 8082, right? And the endpoint that we decided to create, let's see the controller class, right? So this is the, and then let's say I'll just put in the part 1, right? So let's see. Okay, you can see that the price per unit for brake fluid is 30, right? So what's happening in the background is it's connecting with our parts application, and it's going to the database to get this brake fluid item, right? And get the price for that item, and then it's just printing it out over here. So let's take another example for this, and let's take air filter. So I'm gonna go 7 over here. Okay, so you can see that the price per unit of air filter is 45, right? So this is how one application or one microservice is calling another one, making some communication between these two through REST and HTTP, right? Communicating over the network and then giving the response back as a string for this application. But you don't have to stop it over here. You can do as many things as you want, right? You can create another microservice which does the inventory, which does the payment, or anything. Like sky's the limit. You can do anything you want. So before I would like to show the logs as well, how these two communicate with each other. But before that, are there any questions?
Finn is asking, in companies, which client is preferable, REST client or Fein Client? Is there any other client?
Oh, you mean the REST template or Fein Client, right? I guess.
Yes.
Yeah, so it actually depends on how you want to code it. So I like the way how declarative the Fein Client is. You just have to declare it as you can see over here that it's in a separate class. You just declare that, okay, this is the method, HTTP method I want to use, and this is the URL, right? You just declare it and nothing needs to be done, right? Based on your REST template, how I have used is I have used it in a class, right, which has the business logic integrated with it, right? So that way you can separate it out. It doesn't have to be in the one class, and whenever you want to change something, you just have to change this class. Let's say I change the URL to something else, right? Let's say I I change the URL to XYZ over here, right? What I can do is I can just come to this class, change this. I don't have to touch the business logic. I don't have to worry about that, right? And then it just works fine over here. So if that answers your question.
I think it's more of developer choice what they're
Mm-hmm.
trying to do, and I feel personally Fein Client is little easy when developing when compared to the other one.
Yep. I just want to show you one other thing from the logs as well. So for that, what I need to do is okay, let me before I make it incorrect, I'm just going to copy it. Okay. So I'm just using this package name over here. Service demo equals debug, right? And then what this is doing is I'm just telling the application that I'm using a debug, right? So what I can do with that is for the Fein, I can create a custom configuration class. There wasn't. So I need to annotate it with configuration, and I can define my own log level over here. So which I'm gonna do by copy pasting it from my other one. So Fein configuration. So I'm gonna create a bean over here that says that for this Fein client, I'm just gonna use the logging level of basic over here, right? One other thing I want to add up over here is the name of this application called spring.application name is service demo. All right. So now what I can do is I can restart the application. All right, the server has started. Let me hit the endpoint one more time. All right. So once you have the response, you can go to the logs and then see that here, a call to this localhost directory with the 7 as an ID was made, right? And you get a 200 response, right? Saying that, okay, it was it was okay response, right? The other thing I wanted to show you is we have used Spring Sleuth, which has a unique feature with the trace ID. What this helps is on microservice level, if there are multiple microservices, in case of error scenarios, it's very difficult to track where the actual error originated from. So this trace ID over here helps us to track down where the actual error happened, right? So if you see this trace ID over here, this would be same in the parse application as well. So if you see over here, if I just search, oops. So if you see this last entry over here, it shows that this this trace ID is over here in the parse application as well. And these are two complete different applications just trying to communicate with itself. But using this simple trick, you can you can mitigate any errors that might occur in case of edge scenarios, right? So that's a very useful tool as well. All right, I think that's all for the demo purpose for today. If you have any questions, please do let me know, and Teja as well.
Yeah, and while we're waiting on questions, so I dropped in the chat here, in addition to just opportunities to check out upcoming events that we're hosting, also dropped our YouTube link to see some past events that we have hosted. We are planning to host many more conversations about microservices architecture and other ways to be increasing the efficiency of your development techniques. So one that we have upcoming, no date set quite yet, but coming very soon, is on micro front-end architecture, exploring, as I understand it, how this same type of methodology can be applied to front-end development as well with a member of our team. And we've got a few other talks in the works in this regard as well. So always open to hearing ideas for topics. So if anybody has any, if there's any particular piece of this you'd like to see deep dive, if there's another topic that's related that you'd like to see, that you'd like to discuss with experts, please do let us know. We're always looking for that type of feedback.
One last thing, I'll try to make sure to share the GitHub link on these two projects so that people can check it out as well.
Perfect. So yeah, we really, really appreciate everybody joining, and particularly appreciate Teja and Abhishek for joining and sharing your knowledge here. I even followed most of it, which means that you guys must be really good at explaining it. So that's a good sign. So I hope that everybody else agrees that this was helpful information. So we can stick around for the last couple minutes here in case any other questions pop up. But otherwise, thank you everybody for joining, and we will, don't be a stranger. We'll see you all soon.